Hi, and welcome to my mini lecture on some research terms in psychology. All right, some of you guys, or all of you guys, have probably taken some kind of science class and you know something about different research techniques and ways of data collection and all of that. But when we talk about psychology, sometimes there's differences. Remember, we're talking about living things. All right, so the first thing I just want to kind of share here is when we're talking about research in science, the main goals of science are to be able to describe, explain, predict, and control. And some of these are fairly easy. Describing something's fairly easy. I can take a soda can and I can describe what would happen if I threw it against the wall. But explain it. Why does that happen? Well, all right, maybe with a soda can, if I knew a little bit more about physics and chemistry, I could do it. But when we're talking about living things, it's not always easy. Explanations may vary. If I took a person and shook them and threw them against the wall, what would happen? Lots of things. And I don't know if I could always explain why one person would react violently and another person might sit on the floor and pee their pants or cry. I don't know. So predict, control. One of the activities that I have you guys looking at on the extras on Blackboard is a situation where you're trying to predict people that might become psychopaths as an adult. It's not that easy because we're talking about living things in psychology. So it's a lot harder to basically do the kind of studies that we're talking about, and it's a lot harder to make absolute conclusions. So a couple of things about how do we collect data. I mean, I think most of you understand. I think there's certain quantitative data. We can do test scores, we can do measurements or whatever. That's fine. But a lot of times we're trying to measure something that's not that easy. So what do we do if we want to get data about how someone or something acts, what their behavior is, or what the result of something is? So let me get a subject for you. All right, so our special guest here, this is Blizzard. Cats, we do a lot of animal research in psychology because animals are fun, but also because they're like humans. We tend to use mammals and animals that are intelligent. Crows are another kind of animal. Some of you are familiar with studies with using rats or dogs or whatever. Maybe not so much kitty cats because they kind of like to do what they want. But a lot of times we do rely on animals. They're cheaper, they're convenient, and some of the ethics are not quite the same. So let's say that I wanted to do a study about the behavior of a cat. Let's say I wanted to know what happens if I give her certain kind of treats. Does she listen better? Oh, does she bite me? Whatever, okay? So how would I get that data? How would I know how something was affecting her? All right? So I'm going to put her down before she does actually bite me. So how would I do that? One of the main ways we look for information is observational data. But we have two different ways we can do it. We could do what is called a lab or a structured observation, which you see a lot in psych studies when you talk about studies with the rats and with animals in the cages like pigeons and Skinner boxes, and we'll talk about Pavlov and the dogs. All right, those are studies in a lab, and those are fine, and they're good. One of the main things about them is you can get a lot of control, you know what's going on. Well, what is the drawback? What happens in a lab may not happen in real life, right? So it isn't that animal or that person's natural environment. It's hard to know if we can do this. This is the key. We want to generalize. All right, we want to be able to say in our study that what we do in our study is going to apply to other people, other times, and other places. All right, when you're doing an observational study in a lab, it's not real. Think about some of sex studies where they do, think about that. Let's say we were going to do that kind of a study in a lab. Would that necessarily, what happens there, generalize anywhere else? Not necessarily. So the other option we have with an observation is to do what's called a naturalistic observation. We're going to go out and we're going to watch our subject in the real world. The whole point of naturalistic is that it's natural. So you want to be kind of inconspicuous. You don't want the subject knowing that you're watching and observing, because then that's going to screw it up even more. But there's problems with this too. There's no control. Sometimes you can't just, in a public place, you might be able to watch people. You might not be able to do that in their home. If I were, again, going to do that sex study, you can't really watch them in their home. That's not really going to happen. All right, so this is the thing. As a researcher, you have to do what is best for that study. Understanding there's going to be limits and different kind of restrictions on what you do, the results you find, and what conclusions you can draw from that. All right. So once you have you have an idea. We talk, you can read a little bit about, hypothesis, the theory. A hypothesis is what we're actually testing. So we want something very specific. And again, I'm zooming through some things here. I'll try to keep these a little bit short, just because I know, nobody wants to watch a whole thing on psych research. Well, I might, but I'm probably the only one that does. So that's okay. But the main thing when we're designing a study, though, is we have to know whether we're going to be doing a correlation or an experiment. And one of the biggest mistakes that people that are lay people or people in the media when they report on studies make is confusing these. Reporting results as if they are experimental when they're really a correlation. And as some of you have had what does your statistics teacher tell you over and over and over again? Correlation does not equal cause. Right? Just because two things are related, which is what a correlation is, it shows that two things go together. It doesn't necessarily mean they cause each other. And that is a very natural conclusion we want to make. These things go together all the time. We want to conclude that, in fact, they cause each other. Not necessarily. All right. Let's say, for example, let me give you a good example. Let's say, back in the olden days when I was a little kid, back in the 60s, back when the pterodactyls flew and there were triceratops out in the parking lots, let's say I had a little cold, okay? Not a major virus or anything, just a little cold. All right, I go to the doctor, and pretty much all the time, I would get some kind of a prescription for an antibiotic. All right, they gave them out all the time. So you have a little bit of a head cold, you're going to get an antibiotic. All right, so let's say after a few days, I find out that, hey, I got better. Is it necessarily because of that? Maybe not. I might have gotten better I might have just gotten better on my own. All right, so this is why we need to experiment. All right, sometimes things seem to go together, but we don't necessarily know if they do. All right, or they might go together, but there may be a reason other than cause and effect. Maybe, for example, we know that certain substances are correlated with things. Like, let's say, for example, we do a study and we find out that marijuana use is correlated with low scores on a test. All right, does it necessarily mean that the marijuana use caused it? Not necessarily. It could be that those people are just not motivated, and that's why it affects both of them. Or maybe those people are drinking, or maybe they're not paying attention. And so there might be other things that are cause and effect. So ideally what we want to do is a cause and effect study. So here's my hypothetical. All right. Let's say I have come up with this is again hypothetical, magic pill that would cure a really horrible mental illness, schizophrenia. All right. So far, we don't have a cure. We have things to manage it, but we don't really have a cure. But let's say I did, and I think it's going to work. I need to test it. And you could even take some of this and extrapolate it into stuff with the coronavirus, when we're talking about all these testings. All right, I need to test my medicine. I think it would be good to have 3 groups to do this. All right? One of the groups is going to get my real pill. One of the groups is going to get nothing. This is the control. This is what we're going to do to try to fix that problem I had earlier about me and my antibiotic. Without a duplicate me, God forbid, we don't really know if I would have gotten better without it. So we need a control group to see if these people are going to get better even without the medicine. And then I think we need a third group. And this is a group we would call our placebo group. This is a group that is going to get something that looks just like the real thing, but they don't know that it isn't. All right, so yes, there's a little deceit here. Sometimes in studies we can do it if there's a real purpose. There is one here, because we want to know if it's the actual medication making them better or just the idea, just the process of going to a doctor, getting the med. Is that what's making them better? So we want to be able to test that. Okay. The other thing we have to be careful about in a true experiment is that our groups are all the same. All right, I wouldn't want, if I were doing that study, all my patients with severe symptoms in one group and all my patients with not, really mild symptoms in another one. That would be ridiculous, because now it would be hard to know. Those are what we call confounds. Those are confounding variables. They're varying along with my treatment. So let's say I had a group that had mild symptoms and they got the experimental drug and they got better. Well, now is it really the drug, or is it just the fact that they weren't maybe as sick to begin with? All right, so one of the things we do to make sure our groups are equal is we do something called randomize. We want to randomly assign our groups. And the idea with that is that in theory, the groups will be balanced in terms of pretty much everything. Not just in that case how severe their symptoms are, but other things, their age and maybe their gender and other demographic factors about them, so that for the most part the groups are balanced. Now in theory, that works. In practice, it may not. But that's about the best we can do. All right, so if I have my group of schizophrenic patients and I give them all their different treatments, all right, let's say that all 3 groups improve. What does that mean? It means that my meds aren't working. If they all get better, it just means that they got better on their own, because the control group that got nothing got better too. So I'd be probably crying over that. That means my drug is not really what I want it to be, right? If the groups that got the pills get better, what does that mean? Well, I might be a little happier with that. I could probably sell my placebos all over the place. Wouldn't make a lot of money, but hey. But what that means is that it's the idea of taking that med. Same thing happens in any placebo effect is not just with medication. It can be anything where the person thinks that they're getting something. They think that they're having some kind of a treatment or some kind of a procedure or something that's going to help them. We could talk about it in education, if it's teaching method. If someone thinks it's working, we could talk about it there. So we can talk about it in all sorts of things. But it's the belief, it's the mindset, it's the protocol, it's going through the steps that's making that person improve or getting the result. It's not necessarily the experimental treatment. All right, if, though, only the group getting my experimental pill gets better, that's reason to celebrate. Now, if everything else was held the same, there's no other explanation other than that medication made them better. All right, here's the problem. That's ideal. And we would love to be able to do a true experiment like that with randomized groups. We might even do them double blind, where I don't even know which group is which, so I can't bias my results. That's ideal. But in psychology, and sometimes this also expands to other life science, biology, we often can't do it. We end up doing correlational studies, or we end up doing studies that are quasi-experimental methods. And what that really means is we're doing things, we might be manipulating things, but the groups are not completely random, or there's other factors involved that we aren't really thinking about. Why does that happen? Largely because of things like ethics and practicality. All right, if I really, really wanted to figure out, let's say, for example, especially when we're talking about things that can have a negative effect, and that's sometimes a lot of what we talk about in medicine, and we want to know if there's a side effect. Or we want to know if a certain therapy works. Well, in order to really do that, there's always that chance of something negative, and we have to be careful because of ethical reasons. So I may not be able to manipulate it. I might not be able to take random people and give it to them. For example, let's talk about some of the medications. There may be an ethical thing about, there is an ethical thing about me taking people that maybe aren't depressed, giving them antidepressants just to see what happens. Right? I can't really do that. So a lot of times in these studies, you have people that are already doing things. We talk about substance use, for example. I can't bring in a bunch of subjects in my lab and force them to do illegal substances. It isn't ethical, it isn't legal, it isn't moral. I can't do that. So what do you end up doing? Mostly we look at people that are already doing those things, or at least saying they're doing that. We look at self-reports. People lie, people may mislead, but even so, there's no real experiment there. So that's one of the reasons why a lot of the studies you hear about things that are correlational. Doesn't necessarily mean cause and effect. It could, but it doesn't necessarily mean that. Uh, Another one, again, a controversy people have argued about, that is talking about violence, and a lot of studies have shown relationships between violence on TV or violent whatever and actions. But here's the thing: to do a real true study, you would really have to take random kids and have them doing these violent things, and basically you're manipulating it, not of their own volition, but you're telling them to do it. Well, that you can't do that. So what do? We're looking at kids who are doing that on their own say so, and comparing them to people that don't. And then we want to see, but the thing is, they have other differences as well, and it's very hard to pinpoint cause and effect. It's not impossible, but it's hard. So if you learn nothing else from this little speech today, remember that correlation does not prove cause and effect. Might imply it, it might be there, but we don't necessarily know. And as a good scientist, you have to look at all those possibilities. What else is going on in those studies? All right, that's it for today. Prof. L signing off. And again, don't argue with a psych major, because we like it. Thank you.